Good morning, people. Good morning, and welcome back again to your Unacademy NEET English channel. So quickly, let me know in the chats. Give me some green signal if all of you can hear me, if I'm perfectly audible, visible to everyone. Quickly, my dear students. Let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to everyone. Quickly, quickly, quickly. Quickly. Quickly, people, quickly. Just give me a second and we shall be starting, okay? Just give me a second. Just give me a second and we shall be starting. Just give me a second. I believe I'm perfectly audible, visible, yeah? I believe I'm perfectly audible, visible. Okay, so welcome back, people. Welcome back again. Noel is saying, sir, please keep the badge price between 2K to 3K. Just wait for it, Noel. I'm working on it. Wait for 2 more days and you'll get the biggest surprise of the year. Okay? Just wait for it. Just wait for it. I'm working on it. All right. So first of all, before doing the questions of the chapter chemical bonding, I would want to ask you whether you are done with the chapter or not. Have you seen the marathon of the chapter chemical bonding? I would want the honest answers in the chats quickly. Are you guys done with the chapter chemical bonding? Are you guys done with the chapter chemical bonding? Quickly, let me know in the chats. Let me know in the chats. Perfect, perfect, perfect. And my dear students, there are basically, I would say, every type of question is involved from the chapter chemical bonding in the today's session. You are going to solve the questions, okay? And I'll be helping you in order to solve the questions. So I believe you are ready with your pen and paper. And I want the chat box to continuously move, right? Because you are going to write your answers in the chats, okay? You are going to let me know the answers of all the questions in the chats, yeah? Right? Sir, once I build a hospital, I will call you as a chief guest. Kindly note this. I'll be waiting for that day. I'll be definitely waiting for that day. Yeah? Perfect, guys. So I'll be starting with a very simple and basic question. I mean, you don't have to give it a second thought. With a very simple and basic question, right? Why this question? Because I'm pretty much sure everyone will solve this question. I mean, there is no need to think over it. It is just going to be the confidence booster. So tell me the answer of this question. The attractive force which holds various constituent particles together in a chemical species. What do I call that as? What do I call that as? What do I call that as? Quick, 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 everyone, everyone. No need to think. No need to think. What is it? Don't make mistake in this. Do not make mistake in this. That force of attraction which holds the constituent particles together in a molecule, you call that as the chemical bond, right? You know it already. All right. Look at this particular question. Cation and anion combines in a crystal to form which of the type of compound? Again, a very basic question. I want you guys to write the answers in the chat. Cation and anion combines in a crystal to form which type of the bond? Remember your Na positive cation and Cl negative anion, right? What type of force of attraction do they show? Right? They show the electrostatic force of attraction, right? And that electrostatic force of attraction is something which you call as ionic bond, or you can call it as the electrovalent bond. This is something which you all know already, right? No need to discuss this. I'm pretty much sure you know it. Okay. One more simple and basic question. Quickly, kill it. We are going to be super fast today, guys, okay? Because we don't have to solve. It is just, we just have to read the question and hit the answer. When a metal atom combines with the non-metal atom, the non-metal atom will. When the metal atom combines with a non-metal atom. For example, this is sodium, this is chlorine. This is metal, this is non-metal. Right? When the non-metal atom combines with the metal atom, what happens to the non-metal atom? See, sodium, it loses electrons. So metal atom loses electrons and non-metal atom gains electrons. Right? And when the metal atom loses electrons, its size decreases because it gets converted into cation. And when the non-metal atom gains electrons, its size increases because it gets converted into the anion. So what should be the answer of this question quickly? Non-metal atom is going to gain electron, and due to the gain of electron, its size will definitely increase. Right? Perfect. All right, look at this particular question quickly. All basic questions these are. Which of the following does not represent the Lewis symbols? Among these 4-5 options which are given to us, which of the following will not represent the correct Lewis symbol? The correct Lewis symbol. Quickly, my dear students. Quickly, my dear students. I can see majority is coming up with option D, and I believe you all are perfectly right. Why is that? Because when you write the Lewis symbols, for example, this is carbon. In its outermost shell, there are 4 electrons. So 1, 2, 3, 4. So you have to show the outermost electrons with carbon here, right? But if you look at oxygen, in oxygen, how many valence electrons are there? 6 valence electrons. But over here, they have only mentioned 5, right? So this cannot be. Neon, noble gas, right? How many valence electrons it has? 8. But over here, they have only showed 6. So this cannot be, right? Rest, all the others are correct. So it is going to be second and third, wherein the Lewis symbols are not correctly represented. It is just when you write the Lewis symbol, perfect, you just have to show the valence electrons too, the exact number of valence electrons. I'm sorry. All right. I believe you guys remember the Fajan's rules. According to Fajan's rules, covalent bond is favored by. This is something every one of you should know. As per Fajan's rules, covalent bond is favored by. Covalent bond is favored by small cation and large anion. Right? Small cation, large anion. Due to which polarizability will be more. Right? Polarization will be more, and covalent character in an ionic bond will be more. Right? Again, this is the question which I don't feel any, you have to know its explanation or something. Look at this particular question. Everybody, quick. Guys, I want you guys to write the answers in the chats continuously. The polarizability. You have to write the polarizability order. Right? Polarizability is defined for anions first of all, right? It is defined for anions, and all are anions over here. And I believe you remember when we talk about the polarizability. Polarizability is directly proportional to charge on the anion, and it's also directly proportional to size of the anion, right? Polarizability is directly proportional to charge on anion, and at the same time, it is directly proportional to size of the anion. Now, if you look at all these anions, the charge on every anion is same, -1, right? Charge on every anion is same. Now look at the size. See, you have got fluorine, chlorine, bromine, iodine, and all having negative charges. On going down the group, the size increases. So which one has got the maximum size among all? It is I negative which has got maximum size among all. If I negative has got the maximum size among all, its polarizability will be maximum, right? So what should be the correct answer of this question? Absolutely, it's going to be option A, right? Absolutely, it's going to be option A. Look at this particular question. Look at this particular question carefully. Carefully, guys. LiCl, BeCl2, BCl3, CCl4. The covalent character follows the order. Covalent character follows the order. So first of all, if you look at all these species which are given to us, how exactly you are going to check it? See, guys. This is basically Li positive here. This is Be di positive here. This is B tri positive. And this is C plus 4. Right? Right? I think you are done already. See, covalent character in an ionic bond. Covalent character in an ionic bond. It is directly proportional to polarizing power of cation. It is directly proportional to polarizing power of cation. And polarizing power of cation is directly proportional to charge on cation and inversely proportional to size of the cation. Right? Now look at the charges. Wherever you feel charge on cation more, polarizing power of cation will be more, covalent character will be more. So CCl4 will have the maximum covalent character. CCl4 will have the maximum, followed by what? Followed by BCl3, followed by BCl2, followed by LiCl. It's option C which is going to be the correct answer of this particular question. Right? No need to think a lot. Just Fajan's rules and we are done. The maximum covalent character is shown by. The maximum covalent character is shown by AlCl3, MgCl2, CsCl, SnCl2. Quickly. Again, you can play on the same rule which I gave you. This is Al tri positive here. This is Mg di positive. This is cesium plus 1. This is Sn plus 2. Right? And you know, when I talk about the covalent character, as I told you, covalent character is directly proportional to polarizing power of the cation. Polarizing power of the cation. And polarizing power of the cation is directly proportional to charge on cation and inversely proportional to size of the cation. Right? Yes? Now the charges here are different. So wherever you see charge on cation, the maximum polarizing power of cation is maximum and hence covalent character is maximum. So what has to be the answer? It has to be AlCl3. Correct? Done, understood? I want every one of you to be involved in the chats, guys. Otherwise, it's no fun in solving the questions. See, in this session, there will be no calculations, correct? This is chemical bonding. You just have to read it and solve it. There is no calculation involved. So you have to be involved in the chats. You have to let me know whatever you think. You just write it down in the chats continuously. You just write it down in the chats continuously. All right. One more question. What is the correct order of decreasing ionic character? What is the correct order of decreasing ionic character? You must be knowing your covalent character. It is basically, or I'll say it like this. Covalent character is basically inversely proportional to ionic character. So what you have to do? You just get the order of covalent character, just reverse it. Get the order of covalent character and reverse it. You're done. You're done. If you look at all these options, everywhere it is Pb di positive, Pb di positive, Pb di positive, Pb di positive, right? So cation everywhere is same. Now look at the anions. This is Cl negative, F negative, I negative, Br negative, right? So anion is different. Cation is same, anion is different. So I will not be deciding here on the base of cation. I'll be deciding on the base of anion. And you must be knowing covalent character. It is directly proportional to polarizability. It is directly proportional to polarizability. Polarizability of what? Polarizability of anion, right? And you know, polarizability of anion is directly proportional to charge on anion, right? And also directly proportional to size of the anion. Perfect. Now look at all the anions. The charge on every anion is same. Now here you are going to decide on the basis of size, right? So I would say I negative has got the maximum size. I negative has got the maximum size. Maximum size means maximum polarizability. Maximum polarizability means maximum covalent character. That means least ionic character. So PbI2 will have least. Third will have least. Third will have least ionic character, right? So it is absolutely going to be option D then. All aligned with this? Is it clear? It is just what you have to do. You have to get the covalent character order and accordingly get the covalent character order, reverse the order and get the ionic character order. I hope this is also clear. Look at these species. Look at these species. Select the most ionic and the most covalent. Most ionic and most covalent. You have to select the most ionic and most covalent among the following. What do you think? Most ionic and most covalent. Again, Fajan's rules. Again, Fajan's rules. Again, Fajan's rules. And all those students who are waiting for the 45 days crash course, it is going to come in 2-3 days, okay? Stay tuned to the channel at very minimal cost so that everybody can afford it, right? So that everybody can afford it. Yeah? So what should be the answer of this particular question? Quickly. Select the most ionic and the most covalent. Most ionic and most covalent. You are given with 4 or 5 species, right? First of all, let's decide the most covalent. If I ask you, what is the oxidation state of chromium in CrO5? It's +6, you know, butterfly type structure. You should be knowing it. Over here, manganese is in +7 oxidation state. Lead over here, +2, right? This is +3. Perfect. And this is +4. Correct? So wherever cation carries the maximum charge, that's going to be maximum covalent. So which one is going to be maximum covalent? Mn2O7. Mn2O7. It is going to be maximum covalent. Maximum covalent, right? Now, most ionic means least covalent. Most ionic means least covalent. Which one is going to be least covalent? Wherever charge on cation is going to be least. It's going to be PbO, where the charge on the cation is least. So it is least covalent, that means most ionic. Something which we were supposed to check. Most ionic and most covalent. So PbO and Mn2O7. So it's absolutely going to be option B, which is going to be the correct answer of this question. Right? I hope this is again clear to you. Okay, one more similar type of question. And then we'll move on to one more concept. One more question on Fajan's rules. Quick. Arrange the following in the increasing order of their covalent character. Again, the similar sort of question. My dear students, first of all, look what is different in all the species. Look what is different in all the species. This is Cl negative, Cl negative, Cl negative, Cl negative. So you are not going to decide on the base of anion. You won't be deciding on the base of anion. You have to decide on the base of cation. This is Na positive, Rb positive, Mg di positive, Al tri positive. So which cation? Where do we see the cation carrying the maximum charge? In option 4. So 4 is going to be maximum. 4 is going to be maximum covalent, right? And before 4, it's going to be 3. Perfect. Before 4, it's going to be 3. Now, among first and second, the charge on cation is same. Now decide on the base of size. Lesser the size, more the covalent nature. So 1 will have more covalent nature, and at the end, it's going to be 2. So is there any option like this? This is the increasing order of the covalent characters. 2, 1, 3, 4. I believe it's option C. Yes? Right? First of all, I give priority to charge, and once charge part is done, then I'm giving priority to size. Right? The charge on this cation is more. More the charge on cation, more the polarizing power of cation. More the polarizing power of cation, more the covalent character. So here the covalent character is maximum, followed by this. Now among these two, anion is same, and the charge on cation is also same. Now I shall be deciding on the base of size of cation. Lesser the size of cation, more is going to be the covalent character. That understood, right? Okay, look at this one. Look at the next one. Look at the next one. Which of the following set of molecules will have zero dipole moment? Zero dipole moment. Quickly. Zero dipole moment. Everyone. I'm pretty much sure all those students who have watched the chemical bonding marathon, they should be able to solve all these questions without even hesitating. Quickly, quickly. Quickly. Is it option C? People are saying it's option C. Should I go with option C? Should I go with option C? If you look at option C, over here you got BF3, And you must be knowing BF3. It is the typical example of the molecule having dipole moment 0. Right? Trigonal planar. The type of the molecule is AB3L0. You know it. Then you have got BEF2. BEF2. The type of the molecule is AB2L0. Right? Then you have got carbon dioxide. Carbon dioxide. The type of the molecule is again AB2L0. Right? And you have got 1,4-dichlorobenzene. 1,4-dichlorobenzene. This is chlorine here. All these species, they have got net 0 dipole moment. Net 0 dipole moment. Right? All these species, they have got net 0 dipole moment. So, and you know, all those species which have got 0 net dipole moment, they are going to be non-polar. Yes? Correct? Is it clear, guys? आप हिंदी में क्यों नहीं बोलते? Because English channel है. Should I go on to the next question? Should I go on to the next question? So it is absolutely option C, which is going to be the correct answer of this question. What do you think about this one? What do you think about this one? The correct order of dipole moments. The correct order of dipole moments. See, first of all, BF3. BF3 has got the 0 dipole moment. 0 means least. BF3 has got the least. So it is going to be either option C or option D. BF3 has got 0 dipole moment. We know it. BF3, carbon dioxide, right? Perfect. BF2. All these are examples of the molecule having 0 dipole moment. So it's option C or D. Now, among NF3 and NH3, I hope you remember, we have discussed this in detail in the marathons. NH3 has got more dipole moment than NF3. I hope you remember this. NH3 has got more dipole moment than NF3. Do you remember that? Do you remember that? Anyone wants me to explain this part? If you talk about NH3, this is the structure of your NH3, where nitrogen carries a lone pair here. Similarly, if you talk about the NF3, this is N, this is F, this is F, this is F, and there is one lone pair present here, right? If you look at the first case, among nitrogen, hydrogen, which one is more electronegative? Nitrogen, right? Nitrogen is more electronegative. And the bond moment direction is from less electronegative to more electronegative, less electronegative to more electronegative, less electronegative to more electronegative. This lone pair also contributes to the dipole moment. You should know. Lone pair also contributes to the moment, and the moment due to lone pair is towards the lone pair, right? Similarly, it will go in this direction from less electronegative to more electronegative, less to more, less to more. If you look in this particular case, all the 4 moments are basically converging in one direction, right? Here there will be some cancellations because 3 are downwards, 1 is upwards. There will be some cancellation. So here the net dipole moment will be more, here the net dipole moment will be comparatively less, right? So NF3 has got more dipole moment than NH3. So last one is the correct one. Is it clear? Wait, last one or wait, BF3? Okay, last 2 options are same, is that? Last 2 options are given same, BF3. Okay, this is not option D, sorry. This is option C. As I told you, NH3 has got more dipole moment. NH3 has got more dipole moment than NF3. So it's C. Okay. What about this one? What about this one? What about this one? A neutral molecule XF3 has 0 dipole moment. The element X is most likely to be. Guys, XF3. Few minutes back only we discussed about BF3. It has got the net dipole moment of 0. It has got the net dipole moment of 0, right? Mu net here is 0. Perfect. Done? No need to think about this question. No need to think about this question. Tell me, which of the following is a polar molecule? Polar molecule is the one. Polar molecule is the one whose net dipole moment is non-zero. Polar molecule is the one whose net dipole moment is non-zero. And any molecule whose net dipole moment is 0, what do we call that as? you call that as a non-polar molecule. I believe you know it already, right? I believe you know it already. See, the type of the molecule AB3L0, type of this molecule AB4L2, type of this molecule AB4L1, sorry, AB4L0, type of this molecule AB4L1. These are the types of the molecules. By the way, do you remember how do we check the type of the molecule? Do you remember that? Do you remember that? How do you check the type of the molecule? Let me show you one example so that you will revise that too. For example, I'm talking about SF4. I'm talking about SF4, for example. Sulfur being the central atom. How many valence electrons it has? 6. How many terminal atoms it has? 4. The number of terminal atoms is equal to the number of sigma bonds. Number of terminal atoms is equal to the number of sigma bonds. So sulfur is forming 4 sigma bonds. Sulfur had 6 valence electrons. Out of 6 valence electrons, it is utilizing 4 valence electrons to form 4 sigma bonds. So there will be 2 electrons left as such on sulfur in the form of a lone pair. So 1 lone pair, right? Steric number. Steric number is sigma plus lone pair. 4 plus 1, 5. If steric number is 5, hybridization, sp3d. Type of the molecule, it's going to be AB4 and L1. AB4, L1. Correct? I hope you remember this. We have discussed this in detail in the chemical bonding marathon. If you have not watched that yet, please do watch it. It will be in the playlist of Game of NEET. It will be in the playlist of Game of NEET. Now tell me guys, AB3L0, its net dipole moment always 0. AB4L2, net dipole moment always 0. AB4L0, net dipole moment always 0, right? It is only AB4L1 who will have some net dipole moment. And if there is some net dipole moment, that means it's going to be polar. That means it's going to be polar. Moving ahead. Moving ahead. Which of the following possesses dipole moment? Which of the following possesses dipole moment? Write the answers in the chats. Till then, I'm going to write something here. Quick. Guys, remember one thing. Whenever you see molecules of this particular criteria, AB2L0 to AB6L0, if the type of the molecule is this, AB2L0, AB3L0, AB4L0, AB5L0, AB6L0, AB4L2, AB2L3, you don't have to check anything. Just remember their net dipole moment is going to be 0. So they are going to be non-polar. Just remember it directly. Just remember it directly. Now, you just have to check the type of the molecule, right? I hope everyone already solved this, right? I hope everyone solved this. You just have to check the type of the molecule. If the type of the molecule is among these, that means that is non-polar. If it is not among these, it is polar. Okay? Right? Clear, guys? So it's absolutely option C, which was the correct answer of the question. Okay. Some questions on the VBT. PP overlapping will be observed. PP overlapping will be observed in. Guys, PP overlapping. P orbital of one atom and P orbital of one more atom, they should overlap. So which molecule is that? Hydrogen. Its S orbitals will overlap. H2 molecule, right? If I talk about H2 molecule, this is 1s1 of one hydrogen, this 1s1 of another one. They will overlap, head-on overlap. Hydrogen H, this is Br, right? It's S and it's P. They'll overlap, it's sp overlapping. HCl, this is HCl. It's S and it's P, right? Sp. Now Cl2 molecule. This is Cl, this is Cl, right? This is 3p, this is 3p. This is going to be pp overlapping. This is going to be pp overlapping. Nothing to think, right? Nothing to think. If you talk about Cl, its outermost configuration is 3p5, right? 3p5 means 1, 2, 3, 4 and 5. There is this unpaired p orbital, right, which will participate in the overlapping. All these things are discussed in detail, I believe. Look at this particular question. The angle between the overlapping of s and p orbital. S and p orbital overlap. What is the angle? When s orbital of one atom and p orbital of one atom will come, at what angle they'll overlap? At what angle they'll overlap? 1s and 1p. 1s and 1p. 1s and 1p. How they are going to overlap? How they can overlap in this direction. They can overlap like this as well. In whatever direction they are overlapping, it's always the angle is going to be 180, right? The angle is going to be 180. Which of the following represent zero overlap? Zero overlap, zero overlap. Zero overlap is the case here. See guys, positive, 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 positive. If you remember, I made you understand what these signs exactly are. These are not charges. They just tell you whether the overlap is positive, negative or zero. Positive, positive, same sign on same side. So this is positive overlap, right? Opposite sign on same side. This is negative overlap, right? And over here, do you see any overlap here? Is there proper orientation here? There's no proper orientation. So this is the case of zero overlap. This is the case of zero overlap. Same sign, same side means positive overlap. Opposite sign, same side means negative overlap. And this is zero overlap. Correct? See what kind of basic question this is. And do you believe this was once asked in your NEET examination? Do you believe this question was once asked in your NEET examination? Do you believe that? Bond energy. Bond energy. Of course, triple bond will be maximum, followed by double bond, followed by single bond. So why are you thinking a lot in this? There's no need to. The total number of pi bond electrons. Total number of pi bond electrons here. What do you think? A lot of students will just read the question fastly and their option will be option D. I told you, right? See, a lot of students are writing D. A lot of students are writing D. Guys, they are not asking you about pi bonds. They are asking you about pi bond electrons. You have to read the question carefully. One pi bond means 2 pi bond electrons, right? This is a pi bond, this is a pi bond, this is a pi bond, this is a pi bond. So 4 pi bonds in total. That means how many? That means 8 pi bond electrons in total, right? So be careful with all these things. Yeah. Right, people? Okay, so what is the answer of this question? It is 8 pi bond electrons. The molecule not having a pi bond. Molecule not having a pi bond. Molecule not having a pi bond. There is no need to go into the VBT and try to draw the structures. You know it already, right? This is Cl single bond Cl. This is O double bond O. This is N triple bond N. This is C double bond O, double bond O. There is no need to go for VBT and draw the orbital diagram, etc., etc. Don't do that. Don't waste your time here. It's easy, right? Perfect. Or do you want to do that as well? Do you want to see how they are formed? Do you want to see how they are formed as per the orbital diagram? Do you want to see? Yes or no, quickly? Yes or no, quickly? Everyone in the chats. Don't make me wait, yaar. If you want to see, then please and please, there is a session, chemical bonding in Game of NEET I have taught in detail. You can find it in the playlist, right? We have learned that. Okay, coming to hybridization part. Kill it. Kill it, guys. Which of the following molecules represents the order of hybridization? sp2, sp2, sp, sp. From left to right. sp2, sp2, sp, sp. Quickly. How do you check it? Just calculate the sigma bonds. See, this is forming 3 sigma bonds. 2 with hydrogen, 1 with carbon. 3 sigma bonds means sp2. This is forming 1 sigma bond with this carbon, 1 with this carbon, and 1 with hydrogen. 3 sigma bonds again sp2. This is forming 1 sigma, 2 sigma. 2 sigma bonds means sp. 2 sigma means sp. So sp2, sp2, sp, sp. That means option B. No need to think a lot. Okay, these sort of questions I have told you in detail if you remember. In detail if you remember. In the octahedral structure, the pair of d orbitals involved. See, let me tell you, in case of sp3d hybridization, which d orbital is involved? It is dz square, right? This is something which is discussed too. In case of sp3d2, which d orbitals are involved? Dx square minus y square and dz square. In case of sp3d3 hybridization, which orbitals are involved? Dxy, dx square minus y square and dz square, right? Perfect. Now, follow the answer. It's going to be option A. Remember this thing? Yeah? Remember these things? They are asked. See, I told you, look at this one. Look at this one. In ASF5, we have got ASF5. Let's check its hybridization first of all. This is the central atom, arsenic, nitrogen family, 5 valence electrons. How many terminal atoms? 5. So sigma bonds 5. So it had 5 valence electrons, and all the 5 valence electrons are utilized to form 5 sigma bonds. So there is no lone pair, 0 lone pair, right? Steric number, sigma plus lone pair, 5. Hybridization, sp3d. If it is sp3d, that means which orbitals? One of s orbital, 3 p orbitals, which involves px, py, and pz, and which d orbital? It is dz square. These are involved in the hybridization. Now you can mark your answer accordingly. Now you can mark your answer accordingly. Now you can mark your answer accordingly, right? It is option C. Quickly. XEF4. XEF4. This is the central atom. Xenon. How many valence electrons? 8. How many terminal atoms? 4. Out of 8 valence electrons, 4 are being utilized to form 4 sigma bonds. That means 4 electrons will be left as such in the form of 2 lone pairs, right? So steric number, 4 plus 2, 6. Hybridization, sp3d2. Type of the molecule, ab4l2. ab4l2, right? Geometry, octahedral. Geometry, octahedral. Actual shape, square planar. Right? Actual shape square planar. Perfect. All these things are discussed. The species having bond angle of 120. The species having the bond angle of 120. That means it has to be AB3L0. It has to be AB3L0. It has to be trigonal planar. It has to be trigonal planar. AB3L0. It is BCl3, which is AB3L0. Option C. Don't give it a second thought. And guys, at the end of the session, you are going to let me know in the comment section, out of all these questions, how many you did on your own, right? At the end of the session, you are going to let me know in the comments. Right? Even this question, I believe you can easily solve. See, when you talk about water, hybridization is sp3. Expected bond angle is 109 degree 28 minutes. But actual bond angle is 104 degree 5 minutes. What is the reason? The reason is due to lone pair repulsions, right? Due to lone pair, in case of oxygen, there are 2 lone pairs, right? Due to those lone pair repulsions, the bond angle shrinks comparatively. Yeah? The bond angle shrinks comparatively. Already discussed this too. What do you think about this one? What do you think about this particular question? Everyone. PCl5, BRF5, IF7. PCl5, BRF5, IF7. Quick. PCl5, BRF5, IF7. All are square pyramidal. Cannot be. Right? Cannot be. Quickly. Quickly, guys. Question says one of the given compounds is square pyramidal. Let's check it out. PCl5. PCl5. It is of the type AB5L0. Hybridization is sp3d. It is trigonal bipyramidal. Right? BRF5. 5 sigma bonds, 1 lone pair. 5 sigma bonds, 1 lone pair. Hybridization sp3d2. Actual shape of this molecule is 5 sigma 1 lone pair. It is square pyramidal. It is actual shape. Square pyramidal. Then you have got IF7. IF7. The type of the molecule is AB7L0. Right? Hybridization is sp3d3. Right? So it is definitely going to be what? Pentagonal bipyramidal. Now check the options. One of the given compound is square pyramidal. Absolutely right. One of the given compound is square pyramidal. Absolutely right. Okay? Which of the following molecules has more than one lone pair? More than one lone pair. Check it out. More than one lone pair. More than one lone pair. More than one lone pair. Sulfur here has got one lone pair, right? Si, no lone pair. Carbon, no lone pair. Which of the following has more than one lone pair? Is absolutely option B only, right? There's no second thought in this question. XeF2 is isostructural with XeF2. XeF2, its type is XeF2. Its type is AB2L0. It is isostructural with. Check those species among all which has got the same type. Which one will be AB2L0? Which one is going to be AB2L0? Which one of the following is going to be AB? Oh, sorry, it's not AB2L0. Sorry. It's AB2L3, right? AB2L3. AB2L3, sorry, my bad. AB2L3, because 2 sigma bonds and 3 lone pairs. Now, where do you see 2 sigma bonds and 3 lone pairs? If you look at ICl2 negative, iodine is the central atom. How many valence electrons? It should have 7, but there is a negative charge, so 7 plus 1, 8. How many terminal atoms? 2, so sigma bonds 2. Out of 8, 2 are used to form 2 sigma bonds. So there are 6 electrons left as such on iodine in the form of 3 lone pairs. So lone pairs 3. So type of the molecule absolutely is going to be AB2L3, right? So isostructural with the given species. Yes? Done? Which of the following is correct? Which of the following is correct? Which of the following is correct? Done? Which of the following is correct? Did you check it? I can see a lot of students are coming up with option C. Let me check it too. ClO4 negative. See, ClO4 negative is the central atom. 7 valence electrons. Negative charge, so 7 plus 1, 8. Right? How many sigma bonds? 4 sigma bonds. Since oxygen is divalent, right? So out of 8, all the 8 valence electrons are used. All the 8 valence electrons are used, right? So there is no lone pair because it's divalent. It's not monovalent, right? So the type of the molecule is AB4L0. AB4L0 means tetrahedral. AB4L0 means tetrahedral. Done with this too? Perfect. Okay, what is not applicable to TeCl4? What is not applicable to TeCl4? What is applicable for TeCl4? Let's try to see what this TeCl4 is all about. Let's try to get all the data about this TeCl4. Te, it belongs to oxygen family, right? It belongs to oxygen family. How many valence electrons? 6. How many sigma bonds? 4. How many lone pairs? 1. Steric number? 4 plus 1, 5. Type of the molecule? AB4L1, right? AB4L1. Now what else do we need? Okay. Steric number 5, hybridization, sp3d. Actual shape of the molecule, seesaw. Right? This is the actual shape. Geometry predicted through hybridization, that is trigonal bipyramidal. So check it out. Check it out. Which is not applicable. Is it tetrahedral in shape? It is not tetrahedral in shape. Its shape is seesaw. Right? Its shape is seesaw. Its shape is seesaw. Rest all the things are correct only. I believe this is something which you can easily solve. Anyways, tell me the answer of this question. The number of lone pair of electron on the central atom of chlorine. Central atom of ClF3. 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 ClF3, quick. ClF3, quick. Everyone. How many valence electrons with this chlorine? 7. How many sigma bonds? 3. 7 minus 3 is 4. Right? So 2 lone pairs. Correct? What about this one? H2O has a positive value of net dipole moment, while BeF2 has 0 dipole moment. Why is that? BeF2 has 0 dipole moment because it's linear. H2O has got dipole moment because it's bent. Right? Look at the options now. BeF2 is linear, H2O is bent. That's the reason why BeF2 has got 0 dipole moment and water has got some dipole moment. Yes? Identify the wrongly matched pair. Identify the wrongly matched pair. Wrongly matched pair. wrongly matched pair. I think everyone did it correctly. It is showing PCl5 is trigonal planar. Is that? It is trigonal bipyramidal. It's not trigonal planar. It is not trigonal planar. It's trigonal bipyramidal. What type of hybridization of xenon is involved in XeOF4? What type of hybridization is involved? XeOF4. Just solve it. Just solve it. XeOF4. What type of hybridization is involved? Quick. XeOF4. XeOF4. How many valence electrons xenon has? 8. How many sigma bonds it's forming? 4 plus 1. There are 5 terminal atoms, 5 sigma bonds, right? How many lone pairs are there on xenon? 1 lone pair. Type of the molecule? AB5L1. Hybridization, steric number 5 plus 1, 6. Hybridization sp3d2. Right? Is it clear? What about this question? Let's sit and solve today. Let's sit and solve today. What do you think? Which pair of compound is isoelectronic and isostructural? Isostructural. Those two species where you see the type same. Those two species wherein the type will be same. They'll be isostructural. They'll be isostructural. Look at the types now. Look at the types now. Look at the types now. If you look at IBr2 negative, it is AB2L3. This is also AB2L3. Right? Both are AB2L3. Type is same. Type is same. No second thought over it. No second thought over it. No second thought over it. Right? No second thought over it. What about this question? Match the xenon compounds in column 1 with its structure in column 2. You have to match the structures. You need to match the structures. XeF4, square planar. XeF6, XeF6, 6 sigma bonds, 1 lone pair. 6 sigma bonds, 1 lone pair. Distorted octahedral. XeOF4, 5 sigma bonds, 1 lone pair. Square pyramidal. XeO3, 3 sigma bonds, 1 lone pair. Pyramidal. I think you can match it. You should be able to match it, right? Correct? Correct, guys? Anyone wants me to solve this? I think it's done. I think these sort of questions you can easily solve from now on. Asha, one more question on this, then I'll move on to the next part. Hybridization of nitrogen in all these. This was last year asked in your JEE mains examination, a simple basic question. NO2 negative, NO2 negative, 2 sigma bonds, 1 lone pair. AB2L1. Sorry. AB2L1. What is it? AB2L1. 2 sigma bonds, 1 lone pair. Steric number 3, sp2. Right? No 4 valence electrons. All of them are used. 2 sigma bonds. sp hybridization. This is sp3. Is there any option like this? sp2, sp, sp3, sp2, sp, sp3. Yes. Option A. Right? Right, people? Do you want me to explain this question again? For example, you have got NO2 negative, right? NO2 negative. Nitrogen is the central atom. How many valence electrons? 5. There's a negative charge. 5 plus 1, 6. Terminal atoms are 2. So sigma bonds are 2. Oxygen being divalent. So one oxygen will use 2 electrons, right? Out of 6, since 2 bonds are formed, that means 4 electrons are used. Out of 6, 4 electrons are used. That means 2 electrons will be left as such in the form of a lone pair. So 2 sigma 1 lone pair. Done? Right? Okay. Which of the following structure is most stable? ClF3. See, no need to go look at all these. ClF3. I hope you remember ClF3 is AB3L2, right? AB3L2. AB3L2, which is linear. AB3L2, which is linear. You know it. Sorry, what am I saying? It's linear. It is AB3L2. It's not AB2L3. AB3L2. It has to be T-shaped. In this particular shape, the repulsions will be minimized. Now look which one is T-shaped. Yes, Shahrukh, everywhere you'll consider that. Where is it T-shaped? In the first one, it's T-shaped. See, just omit these lone pairs. Now look, it's T-shaped. So option 1 is correct. We know it as per your VSEPR, it has to be T-shaped. Because in the T-shaped one, repulsions will be minimized. Right? What is VSEPR based on? As per VSEPR, we have to arrange the electron pairs in such a way that there are minimum repulsions between them and maximum stability. Right? Minimum repulsions and maximum stability. And this is the shape wherein there are minimum repulsions between the electron pairs and maximum stability. We know it already. Why do we need to consider here the repulsions extra again and again? No. Just we know the shape, that is the shape. Which of the following species is not expected to exist? If the bond order of the species is less or equal to 0, we say the species does not exist. We say the species is not viable. Does not exist. Just use the MOT. Use the molecular orbital theory and let me know quickly. Use the molecular orbital theory and let me know quickly. It is He2 positive. It's not He2. It is He2 positive which is mentioned. In He2 positive, how many total electrons will be there? In He2 positive, how many total electrons will be there? 1 helium contains total 2 electrons. So 2 helium will contain 4 electrons. There's a positive charge, so there are 3 electrons in total, right? Sigma 1 is 2. Sigma star 1 is 1. Correct? How do you calculate the bond order? Half of number of electrons in bonding minus anti-bonding, right? 2 minus 1 is 1, 0.5. So A is not the answer. A is not the answer. Basically, you have to calculate the bond orders with the help of molecular orbital configuration, right? And once you get the bond orders, wherever you see bond order less or equal to 0, that molecule won't be existing. In Be2, 1 beryllium has got 4 electrons in total. So 2 beryllium atoms, 8 electrons. Now you have filled those 8 electrons here. So how many bonding? 2, 4. 4 bonding, 4 anti-bonding. 4 minus 4 by 2. It comes out to be 0. There's no second thought for it. Okay, this question I believe you can easily solve. This question. Identify a molecule which does not exist. Which molecule does not exist? Which molecule does not exist? Which molecule does not exist? He2, 1 helium has got 2 electrons, 2 helium has got 4 electrons in total. So sigma 1 is 2, sigma star 1 is 2, right? Sigma star 1 is 2. 2 bonding, 2 anti-bonding. Bonding minus anti-bonding divided by 2. Bonding minus anti-bonding divided by 2. Bonding minus anti-bonding divided by 2. Why you are saying C2? C2 has got the bond order of 2. I hope you remember. This is C double bond C. And in case of this particular species, both these bonds are pi bonds. Right? I hope you remember already discussed. These are 2 pi bonds in C2. Cannot be B. Don't spam with the wrong answer. It's not B. It's not B. Okay. Which of the following is paramagnetic? Paramagnetic. How do you check whether the species is paramagnetic? So first of all, you write the molecular orbital configuration. First of all, you write the molecular orbital configuration. In the molecular orbital configuration, if you see any unpaired molecular orbital, if you see any unpaired molecular orbital, be it bonding or anti-bonding, that species is said to be paramagnetic. This is the simple rule. Simple rule, nothing else. If you talk about O2, if you look at its molecular orbital configuration, there'll be two unpaired molecular orbitals. There'll be two unpaired molecular orbitals. And if there are molecular orbitals which are unpaired, look here. Look here. This is 1 and 1, 2. There are two unpaired molecular orbitals. If you see unpaired molecular orbitals, you are sorted. That species is paramagnetic. Okay, the total number of anti-bonding electrons in O2. You have to write its configuration. You have to write its configuration. The total number of anti-bonding electrons in O2. You have to write its molecular orbital configuration. Then you can decide. Then you can decide. Then you can decide quickly. Then you can decide. If you look at the molecular orbital configuration of O2, how many total anti-bonding electrons are there? 2, 4, 5, and 6. 6 total anti-bonding electrons are there. It is just, you have to write the molecular orbital configuration and you are done. That's it. Okay, when O2 gets converted into O2 negative, how it gets converted? If one electron is added. When O2 gets converted to O2 negative, that means one electron is added. In which molecular orbital that one electron goes? In which molecular orbital that one electron goes? In which molecular orbital that one electron goes? Quick. In which molecular orbital that one electron goes? Quickly, quickly, quickly. Quickly. In which molecular orbital that one electron goes? Right now only you saw the configuration, right? What was the configuration of O2? Just a second. What was the configuration of O2? This was the configuration of O2, right? Pi star 2px1, pi star 2py1. Now one electron is being added. So that one electron will go here first. Pairing will happen. The extra one electron will go here. Right? So from O2 to O2 negative, where is the electron going? The electron is entering into this pi star 2px. Pi star 2px, right? Pi star 2px. This is something which you know now. Tell me the answer of this question. Which of the following diatomic molecular orbital species has got only pi bonds as per MOT? Only pi bonds. Answer I gave you like a few minutes back only. Only pi bonds. It is C2, which contains 2 pi bonds. Right? C2, its bond order is 2. Its bond order is 2, and also these 2 bonds are pi bonds. And this explained by MOT. Which of the following pair of the species have same bond order? Do remember isoelectronic species. Isoelectronic species. Isoelectronic species are the ones which have got same number of electrons. Same number of electrons. And isoelectronic species are the ones which have got same bond order. Which have got same bond order. Right? Which have got same bond order. Right? Now, which one are isoelectronic? See, CO, carbon has got 6, oxygen has got 8. So 14, 6 plus 7, 13, 13 and negative charge, 14. So these two are 14 electron species. Isoelectronic, their bond order will be same. And that's going to be 3. That is going to be 3. Tell me the common feature among these species. Common feature among these species. First of all these will be isoelectronic. 14 electrons each. Cn negative, CO, NO positive. 14 electrons each. And 14 electron species always has the bond order of 3. In order to remember, you can remember it like this. 14 electron species have got the bond order of 3. 15 electron species have got the bond order of 2.5. 16 electron species have got the bond order of 2. 17 electron species bond order of 1.5. 18 electron species bond order of 1. 10 electron species bond order 2.5. 12 electron species bond order 2. 11 electron species bond order 1.5. And 10 electron species bond order 1. You can remember it directly as a trick. You can remember it directly as a trick. You can remember it directly as a trick. Right? After 14, decrease by 0.5, 0.5. Before 14, decrease by 0.5, 0.5. That's it. Right? So bond order 3 and isoelectronic. This is a common feature among all. Now you should be in a position to answer this question. You should be in a position to answer this question. First of all, you know your bond order is directly proportional to bond strength, directly proportional to bond dissociation energy, inversely proportional to bond length. Right? Okay, now anything can be asked. In this particular case, they are asking you about the bond order. O2 is a 16 electron species. 8 2s are 16. Right? O2 di-negative. O2 di-negative is the 18 electron species. And then we are given with O2 negative. O2 negative is a 17 electron species. O2 positive is a 15 electron species. Right? Few minutes back only I told you. 16 electron species bond order 2, 18 electron species bond order 1. Here you will be having, this was 16, so this is 1.5 and this is 2.5. Right? These are the bond orders because I gave you the order right now only. Now arrange accordingly. Arrange accordingly. This was the order which was given to you, right? This is the order which is given to you. So you identified the total electrons in these. 8 8s are 6, 8 to 16. So this is 18, this is 17 electron species, this is 15 electron species. Right? There is no need to think a lot in this question. There is no need to think a lot in this question. Okay, one last question. This is one last question, and this question I'm giving you as the homework. Do let me know its answer in the comment section of this particular video. Right? Do let me know the answer of this particular question in the comment section of this particular video. Whatever we have discussed, do you think every single pattern of question was done in the marathon? Do you think that? Yes, Zuhaira, 2 p.m. Prahar batch special classes there, yes. Done? So do let me know in the comment section which chapter do you want the next for the problem practice, and stay tuned for the 45 days crash course batch which is coming soon. Okay? Hello guys, take care. Do let me know its answer in the comment section, and at the same time, do let me know the next chapter which you want me to do for the question practice. Take care. God bless you all and love you all.